Hello guys, welcome back to Maths Zone African Motives. Still working on integration. We have got a question, actually two questions that we are going to focus on the general simplification of our integration. So the first part that we are given is to evaluate the integral of x cubed plus 1 to the exponent of 2 with respect to x. So there we are supposed to apply the general rules, or what we are referred to as the exponents, the powers of x in this case. Remember that in our integration, we were referring that the integral of ax to the exponent of n, that is with respect to x, this with respect to x is equivalent to ax to the exponent of n plus 1, everything over n plus 1 plus the constant of integration. And we also ought to understand that the integral of a constant, let's just say it's a with respect to x, this is going to give us ax, that is a times x plus the constant of integration. Basically, when you are dealing, or when you're working with the exponent or the powers of x, what you need is to understand these basic two parts that we have of an exponent and the integral of a constant. So the first part is to evaluate the integral. We are given x cubed plus 1 to the exponent of 2 in this case. All right. So if we are to take this question into consideration, we have got the integral of x cubed plus 1, everything being raised to the exponent of 2 with respect to x. So in order for us to apply this part that we have, what we need is to expand the brackets that we are given. So we are going to expand our brackets so that we can integrate each and every term separately. So this is to the exponent of 2, or to the power of 2, which is an advantage that we have. Remember that a plus b to the exponent of 2 is equivalent to a squared plus 2ab plus b squared in this case. So this is a squared plus 2 times the product of a and b plus b squared. So this is the one that you're going to apply, this representing our a and this representing our b. So meaning to say, we are going to have the integral of that's a squared, meaning to say we are going to raise our a, which is x to the exponent of 3 to the exponent of 2 in this case. That is what is referred to as a squared. An exponent multiplies, so this is going to be x to the exponent of 6. So in this case, we are going to have x to the exponent of 6 plus 2ab, that is we are going to multiply 2 times a times b. So we are going to have this as 2 times our a being x cubed. So our a being x cubed and our b being a 1. So this is going to give us 2x cubed in this case. So we're going to have 2x cubed plus the last term being b squared. So that is b squared, which is 1 squared. And we understand that 1 squared is same as 1. So this is what you're going to have at the end. Or you can simply expand the two brackets as usual, x to the exponent of 3 plus 1 into x to the exponent of 3 plus 1, since this is being squared. And you expand your brackets, you obtain the exact solution from there. All right, so this is what you're going to have, which is the expansion of brackets that we had from the exponent of 2. Now we can integrate each term separately with respect to x. So as we saw that whenever we're given an exponent, we are going to apply this concept that we add 1 on the exponent, that is n plus 1 from the n that we had before. We divide by the new exponent, that is the one that we are having here. If it is 3, this is going to be 3. If this is 5, this is also going to be 5. That's the same exponent. So we're going to add 1 in each and every term. So if we add 1 on 6, this is going to be a 7. So we are going to have this as x to the exponent of 7 over 7. The new x we divide by the new exponent that you're having. The same thing here. If we add a 1, this is going to be 4. So we're going to have 2x raised to the exponent of 4. We divide by the new exponent, which is 4 in this case, plus the integral of 1 with respect to x. 1 is a constant. Remember what we referred to, the integral of a constant with respect to x. It's that constant times x plus the constant of it. So we are going to multiply the constant that we are having, which is 1, with respect to, if this is with respect to m, you multiply to m, but this is with respect to x. So you're going to multiply 1 by x, which is going to be 1. Then we add the constant of integration. So this is 1x plus the constant of integration, but 1x simply gives us x. This is just x here instead of writing as 1x. The 1 is just to show us this is ax, which is 1 times x. All right, so from this part, we can simplify further our final answer just to present this properly. So this is same as 1 over 7x to the exponent of 7 plus, we can reduce 2 divided to 4. That is going to be 1 over 2. That's x to the exponent of 4 plus x plus c. So you can just simplify your final answer in this case. All right, so this is how we are supposed to attempt the first question, whereby we are using the general rules that we have on our standard form of basic exponents or powers of x in this case. All right, then if we check 1.2, we have got another integral that we are going to work on again. So let us see if we are going to win in this case. All right, so this is the part that we have in this case that we are going to work from. All right, so let us see our question number 2 in this case. All right, so that's question number 2. So I'm just gonna hope here I'm going to win. All right, so seems like I'm not winning, so I'm just gonna write this question back. That was the integral of the cube root of x. So this is the cube root of x plus 1 over the square root of x. So that's the square root of x plus 3 over x in this case. All right, so this is being integrated with respect to x again. From our exponents, all right, let us check what we have. We've got the cube root of x, which is being taken from our laws of exponents. Remember from our laws of exponents that if x is being raised to the exponent of a over b, this gives us the bth root of x being raised to the exponent of a. So b in the root sign, which is in this case, this is same as this is being raised to the exponent of 1. So as we can see, once this is b and this is a, we are going to have a over b as a fraction. A over b, take note, our a over b in this case. So we're going to have x to the exponent of 1 over 3. All right, so this is going to be x to the exponent of 1 over 3 in this case. All right, then we've got 1 over the square root of x. So the square root of x, from the same concept, this means that there's a 2 here. The square root simply means that there's a 2. This is a 1. So we are supposed to have this as 1 over x to the exponent of a half. But we want to write as x to the exponent of, not 1 over. So meaning to say we have to write this on top. So we are going to introduce the concept that if we are having 1 over x, this is same as 1 over x, which is 1 over x to the exponent of n is same as x to the exponent of negative n. Meaning to say, before the negative exponent, before this part, we had a negative exponent. So to remove a negative exponent, it's 1 over. This is from our laws of exponents. We are out also to understand this. So meaning to say this is going to carry a negative exponent. That's plus x to the exponent of minus a half. Then we've got 3 over x. I want you to take note of 3 over x. We were supposed to write this in the same way or in the same format like this. But remember from our introduction of integration that if we are having x to the exponent of negative 1, this cannot be integrated with respect to x. I want you to see what was going to happen. Remember that you add 1 on the exponent. So if we add 1, this was going to be x to the exponent of 0 over this. We divide by a 0, which means we are going to have a 0 like this. The moment that we have a 0 in the denominator, meaning to say this is actually approaching to infinity, we are no longer having any exact solution there or any exact answer. So meaning to say we are not supposed to have x being raised to an exponent of negative 1. So we are going to leave this as 3 over x. So why leaving as 3 over x? Are we going to have something that is going to, are we going to integrate this? 3 over x. All right, so this is what we have, guys. We're going to integrate this with respect to x. So my question is, are we going to integrate the 3 over x? From which concept? Remember, the integral of k over x is, with respect to x, is equivalent to k ln x plus the constant of integration. Meaning to say, whenever we are having over x. We are going to have this as k ln x. Remember, the derivative of ln gave us 1 over x. So this is the opposite. Now, integration is the opposite of the derivatives. All right, so on this part, guys, let us add our exponent. Remember, we add 1 on the exponent, so that is going to be a third plus 1, which is going to give us x to the exponent of 4 over 3. We divide by our exponent, which is 4 over 3 in this case, all right? Plus, we do the same thing here. We add a 1 on our exponent. So if we add a 1 here, this is going to be a positive half. So that's x to the exponent of a half divided by a half in this case. All right, plus, remember we said k over x. With respect to x is k ln x. So our k in this case, that's a 3. So this is going to give us 3 ln x plus the constant of integration. All right, so you can simplify further our integrals. In this case, we've got fractions which need to be simplified. This is same as 1 over this, 1 over this. All right, so meaning to say, if we divide 1 divided by 4 over 3 from the first part, 1 divided to 4 over 3, this is going to give us 3 over 4. So you're going to obtain 3 over 4, x to the exponent of 4 over 3. 1 divided to 1 over 2, that is going to be a positive 2. So you've got 2x to the exponent of a half in this case, plus 3 ln x plus the constant of integration. So this is what you're going to have at the end, of which you can also apply back these rationals that we had. That is the application of the square roots. If you want, that is going to be from this part, we can have this solution remember we said to the exponent of a over b from this part here to the exponent of a over b, that's the bth root of x. The denominator is the one that you write inside of the root sign, and the exponent, the fraction, the numerator of the fraction becomes your exponent. So this can be written as 3 over 4. That is going to be the cube root. In this case, we are referring to the 3 in the root sign. Then the numerator here, the 4, becomes your exponent, all right? Plus, in this case, this is to the exponent of a half, which is the square root of x. So this means there's a 2 inside, but you don't write that 2, all right? Also, the 1 and exponent, there's no need for us to write it, all right? So this is plus 3 ln x plus the constant of integration. So this is how you can also present your final answer from this one that we're having here. We can have our presentation in terms of the root signs like this, the way that we see. All right, so these are the typical questions that you are going to be having on integration when you're working with the exponents, powers of x, from the simple integrals that we are having from the basics of our integrals. So I just hope this part we understand. If not, make sure that you watch the video on the introduction of the integration part, so that you understand everything that we talked about from this part. But for now, that's it, guys, from Maison African Motives. Till we meet again.